Incredible question here. Let's give it a go. I'm going to talk about two different ways to do it. So we've got an m-gon, an n-gon, and a p-gon, and we are basically trying to work out what is the largest value that p could take. So we're trying to maximize the angle, the interior angle here, and therefore we're trying to minimize the interior angle here, or there's a little bit more to it. Because the smallest that the m-gon could be would be an equilateral triangle. Then you'd get 60, and then the same for the n-gon, you'd get 60 again. But that would mean the p-gon has an angle of 240, and that's not possible because the maximum it can be is 180. But it's a good starting point. Clearly, 60 and 90 will also give something that's more than 180, and 90 and 90 will as well. But that's kind of like the cutoff. Anything more than 90, like if it was 90 and 108, for example, that's a pentagon, then we'd be okay. And I'm going to go with that for the moment, although you've got to be really careful because I've not exhausted all the values for 60, but I'm just going to do 90 and 108. That would give 198, and then I'd left with 162 here. Okay, that's okay, and that's going to be the largest angle I can get in my p-gon if I use 90 and something above. So what would happen here? Then for here, my exterior angle would be 18, and I would do 360 divided by exterior angle to get the number of sides, which are going to be 20. So I can definitely get a value of P of 20, but the question is, can I do any better? And if I do 90 and some bigger angle, then of course I'll get a smaller angle here, all right? So I don't want to do that. The one thing I've not looked at yet is back to the 60, okay? We know that 60 and 90 didn't work. 60 and 120, that's a hexagon. Okay, that's also not going to work because I get 180. But what about if I went with 60 and the next sided shape? So a seven-sided shape. Okay, this is an awkward one because of the interior angle. So it's 5 times 180 divided by 7, which is 900 over 7. 128 and 4 over 7. So if I combine my equilateral triangle with a heptagon, okay, I'm going to get an angle. I'm going to get, when I add these two together, I'm going to get 188 and 4/7. So I need to think I need to subtract this from 360 or think what do I add on to get to 360? Um, it's going to be 150. Oh, that's too small. So I'm trying to get 360. Oh, okay, if I add on 112, then I'd get to 304 over 7. Okay, so I need to add on another 59 and 3/7. Okay, it's a bit of an unconventional way of figuring out this angle, but I'll get there. So that's going to be 171 and 3/7. So that would be the angle in my p-gon. And that is bigger than this 162. The only question is it possible to achieve? So let's see. So if I had 171 and 3 over 7, then the exterior angle would be 8 and 4 over 7. Okay, because that gets, they add up to 180. So then I need to do 360 divided by 8 and 4 over 7. Now 8 is 56 over 7, so it's going to be 360 divided by 60 over 7, or 360 times 7 over 60. 60 cancels with this, and I get 42. So it is achievable. We can do better. not just 20, 42, but we can't do any better than that, okay? Because that is the best I can do with 60 and another angle. And when we did 90 and another angle, we got 20 sides. Of course, if you go with a bigger angle and another bigger angle, you're going to have a little smaller one here. So hopefully I've convinced you that is the largest that the angle can be. And we've also proven that it does actually relate to a polygon. So incredible question. That is if you have three regular polygons around a point, the maximum value that one could take is 42. Right, let's have a look at a very different approach to doing this question. I quite like that first approach. I think it's just quite intuitive, easy to like sort of visualize. It can be that you miss, you kind of miss this solution to be fair, because it's such an awkward one with this heptagon. Okay, that's the only danger. But if you just like systematically work through it and not make any mistakes, you get to 42. So method two is to work algebraically in terms of the interior angles. So let's look at the interior angles around a point. It's going to be the number of sides minus 2 times 180 divided by the number of sides. That will be this angle here. And if I add it on to the other polygons, very similar. Then this is clearly going to be 360. Okay, now that looks awkward, but as always, we can play around with these things and simplify it. So I'm going to first of all just actually divide through by 180. This just becomes 2. And then I'm going to multiply, oh, sorry, that should have been a P. Then I'm going to multiply through by M and P. So I'm going to get NP, M minus 2, plus MP, N minus 2, plus MN, P minus 2, equals 2MNP. Okay, I mean, you might think this is making it a little more complicated, but at least I got rid of the fractions. And then let's see what happens. NPM minus 2NP. So I've got 2MNP on the right-hand side, and I've got two lots of it over here. So I'm just going to cancel them out. Then I can write that MNP is equal to 2 NP plus MP plus MN. Okay, it is simplifying, just trust me on that. So now I'm going to divide through by MNP. Actually, I'm going to divide through by 2 first, so I can write a half here. Now I'm going to divide through by MNP, and I'll get a half is equal to 1 over M plus 1 over N plus 1 over P, which is much simpler than originally. It's got to be said. Okay, so now we're trying to basically solve this equation given that M, N, and P are all whole numbers. Now, there's one thing I kind of missed. I'm just trying to remember. Well, that's it. Like from this, it might be tempting to use exterior angles, and actually you could get there a bit quicker. Or a result that we find out is like if we times back through by 360, then you'd actually get 180 equals 360 over M plus 360 over N plus 360 over P. In fact, when you add the exterior angles of these shapes up, you get 180. And you might, is that an obvious result? I'm not quite sure it is, but it would be here, here. Like you can kind of see from the diagram that it is going to be true. I've proven it, but like it might be but you kind of could figure that one out and get to this equation much quicker. That's all I'm trying to say. In any case, we're here now, so let's try and solve it. So the first thing to say is that clearly 1 over m plus 1 over n is got to be less than a half because this thing is positive. 1 over p is positive. So that is a useful result to know. And we want to make p as big as possible. That was the whole point of the question. So therefore, make 1 over m plus 1 over n. So we want to make 1 over p as small as possible. Therefore, we want to make 1 over m plus 1 over n as big as possible as well. Given this thing here, which I'm going to call star, okay? Yeah, make them as big as possible, but actually they've got to be less than a half. Okay, so now it's just a case of trying some numbers out. Let's try m equal to 3. Okay, let's just say that m is less than or equal to n. So m is equal to 3. That will give 1 over n is less than a half minus a third, which is 3/6 minus 2/6 is going to be a sixth. 1 over n has got to be less than 1 over 6. And that means n has to be greater than 6 if that's the case. Okay, hopefully I've convinced you of that inequality. So I'm going to try n equal 7. So then 1 over p. Remember, we've got this equation that they add to give a half. 1 over p is going to be 1 over 1/3, or it's going to be a half, minus 1/3, minus 1/7. So which to deal with? First, maybe this one. So it's going to be a half. I could do 1/6, couldn't I? Why not do that? Look, I know that half minus a third is 1 over 6, so it's 1 over 6 minus 1 over 7, because actually that's then quite quick to work out. So I've got 7 over 42 minus 6 over 42, it's 1 over 42. P is equal to 42. So we've got the same answer as before. Now, so that is when m is equal to 3. Okay, that is the best we can do. So now we just need to check that we can't do any better. So if m equals 4, then we would get, we can't have n equal to 4 because that would give a half. So we've got that n is going to be greater than m. I'm actually, like I am quoting the solutions right now because they do explain it in quite a nice way. So we've looked at m equals 3. When m equals 4, we can't have n equals 4. So basically, overall, if n is bigger than m, which is greater or equal to 4, then 1 over m plus 1 over n is going to be less than or equal to 1 over 4 plus 1 over 5, which is 9 over 20, which is actually less than 1/3 plus 1 over 7, because this here is 10 over 21. And so that means that this one is the best, okay, using the approach. You just have to check that we can't do any better, and that's, I'm sorry, I hope that is clear enough. If not, you can, like, you might not have done it that way. You might have tried m equals 4 and n equals 5 and then 6 and m equals 5 and so on, and seen that way that this is the best way that you can do. So, okay, I'm going to say that I prefer this first method. I like it, but I do take the merits of the second method, and it's good to see two different methods. Okay, well done on this question and this challenge overall.